We've been working on the learning target to understand and apply the distributive property in expressions. And this is going to be some practice on doing that. You've watched my video already. We've done some guided practice as a whole class. And now we're going to do some independent practice. Hopefully you've had a chance maybe to do 1, 2, and 3. And so you're going to take a little break. You're going to watch the video, see how you did. If you get something wrong and you don't understand, pause the video and come see me and we'll work it out. We'll figure out what you're doing. So let's check this out. This independent practice number 1. It's just as 9 times 44. I could do it on a calculator easily. It says do it mentally, which means I'm just going to do it in my head. And the way I'm going to do this, 44 times 9, that's really kind of complicated. But if I break that up to 40 and 4, then if I do 9 times 40, and then I add it to the 9 times 4, that makes it so much easier. Because 9 times 40 is 36, add my 0. 9 times 4 is 36. I add those together, I get 396. Then just in a few seconds, I was able to do 9 times 44. But I had to break it apart a little bit. And that's the same case with number 2, where you have this 4 times 5 and an eighth. I look at that and I think, oh boy, 4 times a mixed number? I guess I could make the mixed number into an improper fraction, and then make 4 into an improper fraction, and then I could multiply them and then simplify. Nah, not going to do it. Going to do it 4 times 5, and then 4 times 1/8. So I'm going to break it apart and just make it easy on myself. So 4 times 5, and then I'm going to add that to the other part of the equation, 4 times 1/8. So 4 times 5, that's 20. That's easy. And I'll just make this into 4 over 1. That's 4 over 8. 4/8 is 1/2. I know that. So I have 20 plus a half equals 20 and a half. Okay? Using mental math. Do the same thing with this one. 7 times 3.8. Oof. That's kind of tricky with a decimal, but if I think about it and I break it apart, not too bad. 7 times 3, and then add that to my 7 times 0.8. I'm just multiplying this to this part of it, and this to this part of it. Okay? So let's do that. 7 times 3 is 21, plus 7 times 0.8. Well, I know 7 times 8 is 56. But I have 1 decimal point, 1 over, so I got to go 1 in here. So it's 5.6. Add those together, I get 26.6. Using mental math. And also it shows the distributive property being used, which you can see as I move down to the next ones here. This one says use the distributive property to rewrite each algebraic expression. So what I want to do is I have 8 and then these parentheses, which means I want to do 8 times everything in here, everything in there. So I'm going to do 8 times x, which gives me 8 x's, and then I can add those two. So I do 8 times that, and then I do 8 times the 7, which is going to be 56. And that is the same as that. Okay? Let's go over to 5. 6 times 6 parentheses 11 plus x. I need to do everything in here 6 times. So 6 times 11, and I got to add that to 6 times x. So 6 times 11 is 66, plus 6 times x. If I have 6 x's, it's going to be 6x. So here is the same thing as here. Okay, let's do number 6. I I have x plus 1. That's my parentheses. And I have to do the 8 to everything. 8 times the x, 8 times the 1. If I do it, it's going to be 8 times x plus 8 times 1, 8x plus 8. There you go. I distributed this x, or this 8. I distributed this 8 over to the x and over to the 1 because it was the parentheses. Okay. Let's look at number 7, a real tricky one. Okay. Now, this one has a coyote and a rabbit. Coyote can run 43 miles an hour. A rabbit can run 35 miles an hour. So right away I'm seeing that coyote is faster. Coyote can run faster than a rabbit. So if we do the same amount of time, the coyote is going to run more miles. Okay, so this says to write two equivalent expressions and then find out how many more miles a coyote can run in 6 hours than a rabbit at these rates. So let me just break this down. So I want to know how much a coyote can run in 6 hours. Well, if he goes 43 miles an hour and he's got 6 hours, it's going to be 6 times 43. Okay, if I do that, that'll get me how many miles he can go. And that's a coyote. Now, a rabbit, same amount of time, 6 hours, and this time the rabbit runs only 35 miles an hour, and that will give me how many miles the rabbit can go. Now let me read what this says again. Write two equivalent expressions, so, and then find out how many more miles. So it's a difference. So I'm going to subtract these. So this is the miles a coyote can run. Taking away the miles a rabbit can run, that'll give me the difference. That'll show me how many more miles a coyote can run. The other way I could do it, because 6 is the same, is multiplying the 43 by 6, multiplying the 35 by 6. So I'm going to take the 6 and multiply it by 43 minus 35. So this will give me the coyote and rabbit. But the 6 gets distributed over both of these. So this right here is equivalent to this. It's two ways to write it. And I look at this and I think, which way do I want to solve it? I could get my calculator and do 6 times 43, and I could do 6 times 35 and subtract them and find how many more miles the coyote runs. But I look down here and I see if I do the parentheses first, 43 minus 35, I know that's 8. And then I bring my 6 down. 6 times 8 equals 48. So 48 is how many more miles a coyote will run in 6 hours than a rabbit at these rates. So this actually helped me to solve it mentally, whereas this way I would have had to do some long multiplication or used a calculator. Okay? Tricky one, but that's how you do it. If you ever have a question, just pause the video, raise your hand, we will talk it through. Alright, let's go on. Factor each expression. Now the way you factor an expression is you find something that goes into both numbers. And you kind of want the greatest common factor, if you can. Kind of makes it the easiest. So I'm looking at 8 and 16. I look at 8, and in 8 I have 1, 2, 4, 8, and all of those go into 16. So I'm going to take the biggest one. I'm going to take 8, and then I got to ask myself, how many times does 8 go into 8? Well, just 1. Plus, how many times does 8 go into 16? 2. So 8 plus 16 is the same as 8 parentheses 1 plus 2. So I have a unit here. Okay? Now I could figure this out. It doesn't ask you to, but 8 plus 16 is 24. Let's make sure this is correct. 1 plus 2 is 3 times 8, 24. So it does give me the same thing. Okay? Let's look at number 9. Oopsie. I know that 2 will go into both of these because they're even numbers. But I bet there's a bigger number. So with 24, I have 1, I have 12. 12 won't go into 54. What about 6 goes into 24? 6. You know what? I'm thinking 6 goes into both. So 6 goes into 54 9 times, plus 6 goes into 24 4 times. So 6, parenthesis, 9 plus 4, all right, times the 6. So you find a factor that goes into both of them. Kind of the biggest one would be the most helpful. When I look at 63 and 81, I know that 9 goes into both of these, so I'm just going to go with 9. How many times does 9 go into 63? 7. Two. So I could make it different. I mean, this would be one choice here, but I could also do 16. How many times does 16 go into 32? 2 times. Plus, how many times does 16 go into 16? Just 1, so that'd be 1x. So it could be 16 parentheses 2 plus x, end parentheses. Okay, let's do the last one on this page, and then we'll go on to the back side. I have 77 times 21. With 21, I know I have 3, 7, 21. I know 21 doesn't go into 77, but I know that 7 does. Okay, so I'm going to take my 7 here. How many times does 7 go into 77? 11, bring my x down, plus, and 7 goes into 21 3 times. And I could kind of play this out here. 7 times 11x plus 7 times 3. 7 times 11x is 77x, plus 7 times 3 is 21, which is exactly the same as where I started. So this does work. Okay? You find a factor, put it on the outside of the parentheses, and inside you put the numbers that go into the original numbers. Okay, let's go on to the next page. And this will be the last one, page number 14 on page 490. Alrighty, so let's see what it says. Refer to the graphic novel frame below for A and B. Okay, I have admission. I remember this one from a few lessons ago. The family night, the individual movie. So let's see what it's asking here. Write 2 equivalent expressions that demonstrate the distributive property for the cost of X tickets for admission and movie passes on a family night. Okay, so X is going to be how many I have. So it's going to be X times $7 plus X times $7.50. Okay, so this would give me, however many individual admission passes I need. And this would give me how many individual movie passes I need for the family night. So that's one way to write it. Another way to write it, because they're both multiplied by X, I could put X on the outside, and then it's going to be multiplied by a couple numbers. It's going to be multiplied by 7 plus 7.5. Okay, so if I would take 7 plus 7.5, multiply it together, add those together and then times it by X, I would get the same thing. So this is the same as this. Now let's go to B. Is it less expensive for a youth to pay regular admission with a movie pass or go on family night? Explain. Okay, so a youth. What I want to do, is it less expensive for a youth to pay regular admission with a movie pass or go on a family night? Okay. Regular admission with a movie pass. So if you need an admission with a movie pass, and we're talking youth, it's going to be $13.50. So this one's going to be $13.50. Now, or go on a family night. So here's my family night. You need an individual admission, and you need a movie pass. So 7 plus 750 is going to be $14.50 for the family night. Okay, so let's see is it less expensive for a youth to pay regular admission with a movie pass or go on a family night? And this one is less expensive. So is it less expensive for a youth? Yes, it is. Less expensive to pay regular admission. Because you're talking about $13.50 versus $14.50. I'm always going to pay the lesser amount. Okay. So hopefully you had some success with these. If you didn't, pause the video, stop it, get my attention, tell me what you're thinking, what don't you understand, and we'll help you to build this understanding of the distributive property.